Hey guys, let's get going on section 1.3 here. We're talking about, in 1.3, we're talking about rates of change and slope. And rates of change are really, really fundamental to chapter 1, but also chapter 2, and also, all the way up through calculus, we talk about rates of change. And a rate of change is just how fast is one variable changing in relation to another variable? How fast is your distance changing in relation to time, for example, is a classic example of rate of change. All right, so what I'd like you to do on these first three here is try these three problems and see if you can figure them out and find the pattern. That's what mathematics is at its most fundamental level, at least in part, is finding patterns, okay, and trying to figure out what the patterns are. So try A, B, and C, see if you can answer them. I'm going to go through them here in just a second, but you should try it first. And I can't stress enough how important it is, or how much better it is to, when you're trying to learn something, to try it first to see what you know about it right now, how you can apply that to the problem, fail or not, succeed or fail, right? Either way, that's fine. And then just check to see how you did. That's what learning is. It's putting your understanding out into the world in some way, getting feedback on it, and adjusting your understanding. Okay, so try these first. Hopefully you tried it. Here we go. Let's talk about this gas example here. So you see that for 2 gallons of gas, it costs $4.60, 3, it costs $6.90, and for 4, it costs what? Well, you notice that it's going up by $2.30 each time, and that tells you that a gallon of gas costs $2.30, so this one has to be $9 and, whoa! Let's try this. $9.20, okay? And then how much does a gallon of gas cost? Well, it costs $2.30. That's the rate of change here. So we could graph this on a x and y plane, right? We could put 2, 3, 4, and we could put the cost on the y-axis, and then what you'd see is a straight line. And the slope of that line would be 2.3. Okay, let's go to the next one, cycling. The elapsed time here on the left, distance on the right. If you work this one out, you should have gotten that there's 6.2 miles is how far this person can go in 24.8 minutes. What is the cyclist's speed? All right, well, the cyclist can go 0.7 miles in 2.8 minutes. All right, and if it can go 7.7 miles in 2.8 minutes, then to figure out the miles per minute, which is how we usually talk about speed in miles per minute or miles per hour, we take 0.7 miles divided by 2.8 minutes, and you end up with 0.25 miles per minute. All right, so there's a little bit more work to be done on that one to figure it out, but hopefully you were able to get the 6.2, and if you weren't, that's fine. That's how that problem works, and hopefully you can kind of update your understanding of it accordingly. All right, clothing. The cost of the clothing on the left and the discounted price on the right. The question is how much does that $74 shirt cost? Well, if you apply the same discount that you had here, you find that it's 52.49. So what I did to figure that out is I took, there's actually several ways you can figure it out, but since it's a discount, I just took the number here, the discounted cost, and I divided it by this price, and that told me how much each shirt would cost. So what you do is you find out that the clothing is discounted by 30%. Okay, so if you take this divided by this, you get 0.7, and that tells you that $17.49 is 70% of $24.99. Okay, so that's a 30% discount, and you should have written there like how you figured out what the cost was for that one. All right, so let's keep going here, talking about slope rates of change. All right. Oh, actually, yes, good. So let's talk about dependent and independent variables. Lots of vocabulary that's really important at the beginning of this, at the beginning of Algebra 2. So dependent and independent variables. The independent variable is the variable that doesn't depend on anything else. So for instance, lots of times it is time. Time and typically doesn't depend on whatever you're comparing it to. So time doesn't depend on distance. The distance is dependent on the time. So let's look at A first though. So the independent variable in this one is the gallons. And the dependent variable is the cost. When you go to the gas pump, how much money you pay depends on how many gallons you bought. The next one, the independent variable is time. And the dependent variable is distance. In the next one, for part C, the independent variable is cost. And the dependent variable is the discounted cost. Okay. So how much is the discounted cost? Well, that depends. What was the initial cost? All right. So that's what the difference between independent and dependent variables is. Let's look at this last one before we wrap up part 1 of the video here. So rate of change. We want to plot the points from the table in 1B. Let's go like this. All right. So before we plot the table, so we're looking at 1B. And so the table should line up. Again, you should try this problem before you just take the notes on it. You will learn it and remember it better that way. But let's plot some points here. We have 10, comma 2.5. So we'll go 10 to 2.5, which should put us right here. So there's a point. Whoops. Oh no. 10, 2.5. Okay, so there's a point. And then we also have 12.8 and 3.2. So 12.8 and 3.2, we'll have to approximate a little bit, but that's going to be like right here. Okay. And then we can also put 24.8 on there and 6.2. So 24.8 and 6.2 would be right here about. And if you do it right, I didn't, not quite right, sorry, but you should get a line like this. And it should also go through 0, 0, because at time 0, you should be at 0 distance. Okay, so there is your line. What is the slope of the line? All right, well, to find the slope of a line, you can take, you may remember that slope is rise over run. That is the change in y's divided by the change in x's. Or, and you could do that by counting, right? So you could go from here, and you can see, well, how far up did we go? How far up? And then how far over? That'd be your rise and your run. So we go up 0.7, and we go to the right 2.8. Okay, so what is the slope? Well, it's 0.7 divided by 2.8. Now you can get that another way as well, but sometimes counting is the easiest. But you could have done this, 3.2 minus 2.5 divided by 12.8. minus 10, and that would equal 0.7 over 0.7 over 2.8, and that gives you 0.25 or 1/4. But so it's 0.25 miles per minute. I ran out of space there. Oh no, I didn't. Miles per minute. Okay. And so you've got that. All right, then what is the y-intercept of the line? The y-intercept is 0, 0. So 0, 0 is where the intercept is. Write an equation that relates the time and the distance. So we have a formula for distance and time. It's this. Distance equals rate times time. We have the rate right here. The rate of change is 0.25. So we have distance equals 0.25 t. Right? And so that's the beginning of rates of change and slope. In the next video, we'll talk more about slope explicitly just in the context of graphs, but these are a few applications of rate of change, which, as you can see in this example, is the same thing as the slope of the line in the problem.